You know, for years, the whole story of AI has been about one thing: scale. Bigger models, bigger data centers, bigger, well, everything. But what if the next massive leap forward in AI isn't about getting bigger at all? What if it's about getting smarter and a whole lot smaller? So let's get into it, because a new kind of AI is bubbling up, and its greatest strength might just be its tiny size.
Seriously, just think about that for a second. We've all gotten used to AI living somewhere far away in the cloud, powered by these giant, mysterious server farms. But what if the most powerful, most useful AI was the one that could live right here, in your hand, on your device?
All right, so to really get where we're going, we first have to understand where we are right now. For the last several years, we've been deep in the era of the large language model, the LLM, and it's all been driven by one simple philosophy: bigger is always better. And look, this race to build bigger and bigger models has given us some incredible tools, no doubt, but it's come at a price. These giant models, with literally hundreds of billions of parameters, they're the Goliaths of the AI world. Incredibly powerful, yes, but also incredibly demanding. And that demand, well, it creates some pretty serious real-world problems. They are ridiculously expensive to run, they're completely dependent on a connection to the cloud, which means lag and slower response times, and maybe most importantly, every single time you use one, your personal data is being sent off to a server owned by somebody else. That just opens up a whole can of worms when it comes to privacy, right? But hey, like in any good story, a challenger has appeared. And this is where we meet our David, the small language model, or SLM. It's a whole new approach that was pretty much born from the frustrations and limits of its giant cousins. Okay, so what is an SLM really? Just think of it as a lean, mean, efficient AI machine. While LLMs are counting their parameters in the hundreds of billions, SLMs are designed from the ground up to be way, way leaner, usually under 10 billion parameters. And that compact size, that's its superpower. Yeah, this chart just lays it all out nice and clear. On one side, you've got the massive cloud-based LLMs that can be kind of laggy. And on the other, you have these compact, super efficient SLMs. They run locally, right on your device. People in the know call this running on the edge. And this makes them blazingly fast, private by default, and they work even when you're offline. But you might be thinking, being small and fast is great, but can these things actually perform? Can they compete with the big guys? Well, to find out, researchers put them through one of the absolute toughest tests you can give an AI: writing computer code. I mean, if they can handle that, they're the real deal. So, how do you even test this? Well, a recent in-depth study gives us the answer. Researchers grabbed 20 different SLMs, put them through 5 standardized coding challenges on some very controlled hardware, and then analyzed every little detail. I mean, this wasn't just some casual kick-the-tires test. This was a proper scientific study. And what they found is super interesting. It kind of confirms what you'd guess, but with a really important twist. Yes, size does matter. It has a clear effect on performance. But, and this is the part you really need to hear, it is not the only thing that matters. You can still get amazing results, even from smaller models. So check out this chart. It shows the first part of that finding perfectly. On average, the bigger SLMs in the study, what they called Group 3, they did in fact do a better job writing correct code than the smaller models. Okay, so far pretty much what you'd expect, right? But here's the catch. This is the trade-off. That little bit of extra performance comes at a huge cost in resources. The study found the real bottleneck, the thing that holds everything back, wasn't speed. It was GPU memory, VRAM. The bigger the model, the more memory it just eats up, which makes it way harder to run on normal, everyday hardware. So how much more are we talking about? Well, the difference was massive. The biggest group of SLMs needed, on average, over 12 gigabytes more VRAM than the smallest group. That is a huge difference, and honestly, it's more memory than most of us have on our regular laptops or phones. So what's the big takeaway here? It's this. The study proved that SLMs can hit this incredible sweet spot. You don't always need the absolute biggest model to get great performance. You can get really strong competitive results from smaller models that are practical enough to actually use in the real world.
Okay, and this is where it gets really exciting. We're talking about taking this AI out of the data center and putting it into our actual lives. This is the whole world of Edge AI, where the smarts are running locally right on your device.
You might be wondering, how is this even possible? Well, a big part of the magic is a technology called quantization.
Think of it like this. Imagine instead of using a super-duper precise number like 3.14159, you just round it to something simpler like 3.14. By doing that to millions of numbers inside the model, you can shrink its overall size like crazy without having to retrain it from scratch. And the result? It's honestly pretty dramatic. Using a technique like this, you can shrink a model's size by as much as 75%.
Okay, so you'd think chopping a model down like that would just wreck its performance, right? Well, here's the kicker. These compressed models still manage to keep the vast majority, we're talking 70 to 90%, of their original accuracy. It's an absolutely game-changing trade-off.
And you can see the applications right here, and they are awesome. We're talking about sensors on a factory floor that can predict when a machine will break, all without an internet connection. Translation apps on your phone that work instantly. Cars with safety systems that have zero lag. Or even healthcare wearables that monitor your vitals completely privately because your data never, ever leaves the device. All right, so all of this is pointing toward a future that really challenges one of the biggest ideas in AI. This notion that real, complex reasoning is something only the giant models can do. And new research is starting to back this up big time. This quote from a very recent paper just says it all. The old idea that the only way to get smarter AI is to just keep making it bigger, well, that idea is being seriously challenged. I mean, think about what that means. It's profound. With smarter training techniques and these new compression methods, we can start to unlock real, sophisticated reasoning in models that are small enough and efficient enough to run just about anywhere.
Which leaves us with this huge, fascinating question about the future we're all building together. Is it going to be defined by a handful of giant, centralized AI brains sitting in the cloud? Or is it going to be a world of billions of small, smart, and hyper-efficient companions working privately and instantly right there with us in our pockets? The rise of the small model suggests that future might be a lot closer than any of us think.